Hello guys, I'm David and today we're going to talk about subnet mask and subnetting. So, what is subnetting? Subnetting is subnetting is a logical method used in networking which actually divides a network into two or more equal parts. So, what is a subnet mask? A subnet mask is a mask where it tells us what are the network bits and what are the host bits. All the network bits which are initialized to one, all the bits which are initialized to one are called network bits, and all the bits that are initialized to zero are called host bits. So which by which we can tell how many hosts can be created in a network. So we have an example. We have an example solved here. So the question goes like this: we have three routers, each router having two LANs which hosts different number of hosts. In HQ, which has two LANs, has 50 each, and branch 1, which has two LANs, has 20 hosts each, and branch 2, which has two LANs, has 12 hosts each. So what we do is we are given one IP address with subnet mask 24, and we are expected to divide, and we are expected to segregate it into 9 different networks. So this is how it's done. We have HQ here, and we have two LANs, and we can consider that this LAN is capable of taking in 50 hosts at a minimum. First we need to understand how subnetting can take place. According to our requirement here, LAN each of the LAN for headquarters has 50 hosts. As we know, we can not get exact number of hosts required, so we go to its closest 2 power network. So the closest number of hosts that can be obtained are 64, which is the closest 2 power, which is equal to 2 power 6, 64. So we need 6 bits of hosts, and all the others can be considered as a network. So totally we'll have around /26 network. So here we have the subnet masks of these two LANs, of LAN 1 and LAN 2 of the headquarters, as 255.192, and this can be considered as one network, which is a subdivided network of /24 network of 192.168.1.0. Since we have created two networks, here. This network is 192.168.1.0 till 192.168.1.63. These are the IP addresses allotted for LAN 1, and 192.168.1.64 till 1.127 are the IP addresses hosted for LAN 2 in the headquarters. Similarly, we have branch 1 and branch 2. Depending on the requirements and depending on the closest number of hosts available for 20 is almost around 32, that is around 2 power 5. So here we create 5 host bits in the subnet mask, and the others can be considered as the network bits. So the network bits here are equal to 27, and the host bits are equal to 5. So we can hold up to 32 hosts in this network, LAN 1 and LAN 2 in branch 1. Similarly in branch 2 we have the requirement is around 12 hosts. So the closest number of 2 power networks we can create are 2 power 16, that is total number of hosts at 2 power 16. So the closest is 2 power 4. So we need 4 host bits, and around 28 network bits, so that can be given as 255, 255, 255, 240. So this is basically our subnet mask for all the three different requirements of three different branches. And I've assigned all the IP addresses for the headquarters LAN 1. I have 1.5, 1.10 similarly, and my gateway for the router and the LAN 1 would be 1.10. Similarly here I've given 70 for the first one, 1.75 for the second, and 1.80 as the gateway. Similarly, I've assigned all the IP addresses for the end users. And another interesting part here would be we need to assign separate networks for the interconnection of these routers. These routers have to be interconnected using a separate network so that they communicate between themselves. We need two number of host addresses. So since we need only two number of host addresses, the minimum requirement for us would be 4, because we need two host addresses, one network address and one broadcast address. So totally the requirement is 4, which is 2 part 2. So we need two host bits and around 30 network bits, which are available even after assigning all the branches their IP addresses. The network that has to be given is the subnet that has to be given is 255.255.252 for the subnet mask. So we assign each of the router their IP address, not exactly IP address but their default gateways. The router's configuration would be 1.225 between the routers, with that serial 2/0, and for serial 3/0 it will be around 229 since it's 252. Another important point is, even after giving out all these addresses, even after interconnecting all the end users to the LAN and LAN to this routers and interconnecting the routers also, they won't be pinging. For this we need to give it as RIP, which is also known as routing information protocol. We go to one of the routers, then we go to one of its command line interfaces, and after going into the command line interface, we type in en to enable. One second, let me show you another one. Okay, we type en to enable, and after that we type conf space t. So we can now configure the router. Now we type in routing information protocol. So now what we do is we type in the network to which it has to be connected, network space to the other routers network. So that will be around 192.168.1.20.5. So since we have given it the route, since we have given branch 1 its routing for branch 2 LAN 2, now we need to give in for each and every other network 202.205. 205 like this we have to assign one router every router's LAN networks. Then as we can see in its routing table, now we can see in its routing table all the networks that are connected to this router. Serial 2, serial 2, serial 3, all these are the routing connections to each of the routers, which are not specifically for this router, but it knows what LAN is present to which router. So this is done, and since now we can try pinging one router to another, let's ping 192.168.1.5, which is present in the headquarters LAN 1 location. So seems it's pinging perfectly, so let's try from another PC. Ping 192.168.1.5. Yep, this is also pinging perfectly. So this is what subnetting is. So hope you have all understood what subnetting might be. So thank you and have a good day.